This is a tutorial on inequalities. The first thing I want to do is review with you some of the other things that we've been asked to do in our math classes. So you've seen words like expressions, equations, and then now inequalities. So this is a good time to go back and review what the difference is in these three things. So when you've had expressions before, you might see something like 5x plus 2. So the difference in an expression and an equation is you'll see that here we have an equals sign, and that's easy to remember because you have kind of part of the word equal inside of that word. So it's easy to get these two confused because you might say 5x plus 2 is an equation, but without an equals sign, it's only an expression. So when we had expressions, you could be asked to simplify them. So maybe if we had another something with an x term or another just number out here to the side, we could combine like terms and simplify. We could evaluate expressions. If it gave us x equals 2, we could plug a 2 in for our x and then solve or simplify that expression, evaluate that expression. Equations, remember though, have that equal sign. So these are the ones that you are solving. So in this one, for example, you would divide both sides by 10, and then you would get x equals 2. So expressions and equations. And now what we're doing with inequalities is we're swapping out that equal sign for one of 4 signs. So an easy example here is 2x is less than 10, but that's not the only type of inequality symbol we could have. We could have less than, we could have greater than, we could have less than or equal to, or greater than or equal to. So this is just one example, but also remember, if you think back to, maybe you learned this in elementary school, but it still holds true today. You may have seen someone draw out maybe like a fish or a shark. My drawing abilities are terrible, but you would want to say that the fish or your little critter that you drew here eats the bigger number. So when you've seen some things like that, maybe in elementary school, and you had to put a symbol in, maybe all you had was something that said like 5 and 10, and you had to come up with what symbol goes in the middle. And maybe your teacher said that the shark or the alligator or something eats the bigger number, right? The other way you can think about it is it's pointing. So if this was an arrow, it's pointing to the smaller number, right? So keep all of those things in mind as you are working on some inequalities in a little bit of pre-algebra and algebra now. So like I said, we have 4 symbols: less than, greater than, less than and equal to, or greater than or equal to. And there's a couple different things they can ask you to do with these inequalities. So I'm going to go through about 4 different things they can ask you to do. So one of these things is to graph an inequality on the number line. So the easiest way to explain it is to dive right into an example. So number 1 says k is less than or equal to 5. So if we have a number line, and I only drew a partial number line here, the first thing that we need to identify is our 5 number. So I would put just a circle there at 5, and then I'm going to reference back to this chart that I drew to see what kind of circle I need, open or closed, and then which way we're coloring in on the number line. So first is, if it has this little equal sign underneath, that means it includes that number. So k can be any number that is less than 5, or it can be a number that is equal to 5. So if it includes that number, and you can see here, less than or equal to gets a closed circle, just like greater than or equal to would get a closed circle. So I'm going to not just leave that as an open circle, but I'm going to color that in, and then I have to decide which direction this is going on the number line. So here you can use some mental math. And if it is any number that is less than or equal to 5, those numbers would be located to the left, right? So, so you would do a colored in dot at 5 because it includes 5, and since it's less than, it's going to the left. Another way to remember that are those 2 L's. So less than, left, right? So you're going to color those in. Let's go over a couple more examples here. I'm not going to go over all of these because I want to do one video that shows you everything about inequalities, or at least half of it. So for number 2, you have x is greater than or equal to -2. Again, since we have that little equal sign included, it's going to get a closed-in dot. But now this time, it's all numbers that are greater than or equal to, so it's pointing in this direction. So you're going to color in the line this way. If you're doing some practice problems on IXL, you'll drop the dot there. You'll click it again to change it between colored and opened. And then you're going to click the end of that arrow. So make sure you scroll all the way over so you're clicking on this so it shades in all of that side of the number line. Number 3 is our first example of one that isn't including that equal sign underneath. This one just says x is less than 8. So on our number line to graph this, we would leave that as an open circle and then shade in everything to the left because it's less than. And again, to think about this kind of in a big picture, yes, it would include 7, but you don't want to start at 7 because there's a million different numbers in between 7 and 8. We don't think about that a lot, but think like 7.5, like 7.75. All these different numbers here are included, so you want to color all the way up to that 8, but leave that open because it does not include the 8. So, one last example, let's look at this one. X is greater than -3. So that gets an open circle on -3 because it doesn't include it. We don't have that equal sign line underneath. And then since it's greater than, it's pointing to the right, so you're going to shade in to the right there. I don't know if you can hear that, guys, but I decided that washing clothes and doing laundry today would be the thing to do while I was recording videos. So that spin cycle is real in the next room over. All right, so let's look at something else they could ask you to do. So in the last one, they gave you the inequality and you graphed it. So they can also ask you to do the reverse of that. So the reverse of that is they would give you a graph and then you have to write the inequality. So I've got a couple little tricks for this one. Just like I thought that the best way to start the other one was to do kind of like an open circle here and then decide if you need to color it in and then which way to shade. The first thing I like to do on these is to write down the number that we're dealing with, right? So this is already done for you, but what I would do is I would say x and then -3, right? I would put my x on my left and my -3 on the right and then figure out what I need from there. So one thing that I know is that this is shaded to the left, so that means less than, right? So left is less than, so I would do this, and then I would check to see if it's an open or closed dot. So this one here is closed, so it includes that -3, so I would add that line. So for this type of section, for these types of problems, you're going to do everything that you just did, but you're going to do kind of the reverse, and you're going to do it in reverse. So let's look at just a couple more practice problems here. This one has an open circle at 1, and then it's shaded to the right. So I would write my x and my 1, and then go back and figure out what inequality sign goes in between. Since it's an open circle and shaded to the right, that would be a greater than sign without that little equal sign underneath because it wasn't a closed in dot. All right, so let's look at one more. Number 3, we have a closed in circle at -2 and it's shaded to the left. So I would write an x and a -2. I'm going to see which way it's shaded to the left. So left means less than. So I'd write that top symbol there. And then since it's a closed in dot, it also gets that little line underneath. So that's what writing inequalities from graphs looks like. Another thing they might ask you to do is to identify solutions to inequalities. What that looks like is this. You may have just one choice and it could say, is this a solution, yes or no? You may have multiple choices and you could have more than one correct answer. So I'm going to walk you through a couple sample problems like this. This type of problem says, which of the following are solutions to the inequality below? And our example here is b is less than or equal to -5. So all we're trying to see is if we plug in this B, does that make that statement true? So let's start at the top. The first one says, for the first answer, choice A, says B equals -7. So if I plug in a -7 here at B, we have to read that and see if that's a true statement. So -7 is less than or equal to -5. And that's actually a true statement, because if we were looking at a number line, -7 would be farther to the left, which would mean it's less than. So that one's true. For B, they ask us to plug in a -6. So -6 is less than or equal to -5. That's also true. For answer choice C, -2. -2 is less than or equal to -5. That is not true. So I put a little X beside that because -2 would be located to the right of -5 on the number line. So it is greater than, not less than. And the same thing is true for number 1 or -1. -1 is less than or equal to -5. That's not true because it would be located to the right on a number line. So let's look at another example here. It says -7 is greater than P. So if we plug in our answer choice A, -3, is -7 greater than -3? That's not true. And another tip is if you want to draw a little number line on your paper to kind of look at these, it's easy to kind of look away for a second or get distracted and then come back to a problem and kind of forget where you were. So you can always draw a little number line, sketch it out on your paper, and see if these are true statements or not. Answer choice B says -7. So -7 is greater than -7. And don't get confused on this one. If it had that little equal sign underneath like it did on number 1, that would be a true statement because -7 is equal to -7. But it doesn't have that. It only says -7 is greater than -7. So that's not true because they should be equal. -6 is also not true because -7 is less than -6, not greater than. And then -8 turns out to be our only correct answer choice here. So if we plug in -8, -7 is greater than -8. That's a true statement. Another type of way that they could ask this, these types of questions is x equals -1 a solution to -6 is greater than x? So all we would do is plug in our -1 for our x here and then see if that's a true statement. -6 is greater than -1. That's not a true statement. So that's what those types of problems look like. The other thing we can ask you to do is solve these problems. There are one-step linear inequalities. There are two-step linear inequalities. So here, we would treat this inequality just like it was an equal sign. So all the things that you've learned in regular, like pre-algebra and algebra, all those same rules still apply. So you want to do the opposite operation to undo something, and what you do to one side, you have to do to the other. So the trick here is when you're putting in your answer or writing down your answer, you don't want to kind of go to your default setting in your brain and write an equals sign. That's what we're used to, and you'll easily get a problem wrong by typing in or writing in an answer like h equals 9 instead of h is greater than or equal to 9. So make sure you double and triple check your signs. So a couple sample problems here. H plus 7 is greater than or equal to 9. To get h by itself, you're going to subtract 7 from both sides. So once we subtract 7, we get 2 on the right. And again, don't write down h equals 2. You want to copy that sign down just as it is. There's a couple exceptions to that. I'm going to show you what that looks like on the next page. So h is greater than or equal to 2. And if you plug that back in, that makes sense. Any number that equals 2 or is bigger than 2, you could put in for that h, and that would make that a true statement. Number 2, s plus 2 is greater than 3. Subtract 2 from both sides. 3 minus 2 is 1. So your final answer here is s is greater than 1. Number 3, r plus 7 is less than 9. Subtract 7 from both sides. 9 minus 7 is 2. So r is less than 2. Number 4, j plus 3 is less than or equal to 10. Subtract 3 from both sides. 10 minus 3 is 7. So j is less than or equal to 7. And one last sample problem here on this page. H plus 4 is greater than 7. I would subtract 4 from both sides. 7 minus 4 is 3. So H is greater than 3. All right. If they can ask you to do addition and subtraction, you guessed it, spoiler alert, they can also ask you to do multiplication and division with these inequalities. Again, all the same rules apply, just as if this was an equal sign. So it feels a little weird. You've got to double and triple check your answers to make sure you didn't accidentally write down an equal sign. But all of the math is still the same that you've already learned. So our first example here is m divided by 2 is less than or equal to 2. Now, it looks funky. We don't like the fact that there is a fraction here. There's a variable. We've got a funky sign. Like, we're not happy about any of this, but all of the same rules apply so we can make it work. So to get rid of division, the opposite is multiplication. What we do to one side, we do to the other. So I'm going to multiply both sides here by this denominator 2. So I rewrote the problem and put a 2 to the left here. Put this in parentheses because that shows that I'm multiplying. What I did to the left side, I have to also do to the right side. This cancels out, leaving me with m on the left side. 2 times 2 is 4, and we've got our answer. Again, I can't stress enough, make sure that you don't write or type in m equals 4, because that's what we've been doing for so many weeks, that's kind of like your default setting. Your fingers are going to start typing an equals sign, and you'll get the problem wrong if you don't have that correct sign there. So just a couple more examples. 2c is less than or equal to 8. The opposite of multiplication is division. So I divide both sides by 2. That gets rid of this. It cancels out your 2 and then leaves c by itself. 8 divided by 2 is 4. So c is less than or equal to 4. Number 3, 2v is greater than or equal to 8. Again, just like up here, the opposite of multiplication is division. So I divide both sides by 2. That leaves me with v on the left. 8 divided by 2 is 4. So v is greater than or equal to 4. B divided by 5 is less than or equal to 2. This is just like our first problem up here. We multiply by that denominator to cancel it out on the left. 2 times 5 on the right is 10. So our final answer is B is less than or equal to 10. I want to skip ahead just a little bit and show you that weirdo example I was telling you about where you have to switch the sign. And so that one for us is down here at example problem number 9. So originally the problem said 2 is less than or equal to t divided by negative 4. When you have to divide or multiply by a negative, you have to flip the sign. So all the math still applies. So I'm going to multiply this side by negative 4. That was the denominator. That cancels out here on the right side. What I do to the right side, I have to also do to the left side. So our 2 that was in our original problem gets multiplied by a negative 4. So that would leave us with negative 8 and t. But you'll notice that I had to flip the sign because I multiplied or divided by a negative number. It went from the less than to the greater than, right? So you have to remember to switch your sign on those. And that really is the toughest part of this week's work, is to remember when you're doing that to swap the sign. And then the other thing is just to make sure that you're putting in your answers in the correct format and not using an equal sign. And that's it.